Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to solve a Leetcode question number 455. Assign cookies. Assume you are an awesome parent and want to give your children some cookies. But you should give each child at most one cookie. Each child I has a grip factor g of I, which is the minimum size of the cookie that the child will be content with. And each cookie j has a size s of j. If s of j is greater than or equal to g of I, we can assign the cookie j to child I, and child I will be content. Your goal is to maximize the number of content children and output the maximum number. So they have given two arrays like g and s. G is a grid factor, and S is the size of the cookie for each child. It is saying that, take for example, there are n number of child and each child demanding some cookies. If you give this much cookies or more than this cookies, I will accept it. Like if I am a child and I am asking for one grid factor, one cookie, then when you are giving one cookie or more than one cookie, I will happily accept it, right? If you if I want 10 cookies and you are giving 9 cookie, I won't accept it. Okay, so they are asking us to maximize the result, that is to maximize the children's, right? We want to give a maximum number of children's, right? We want to give that cookies to the maximum number of children. So this is what the question states. Now see this example: 1 2 3 and 1 1. First child asking for only one cookie. We can give him one cookie or more than one cookie, he will be satisfied, right? So I can give this one. So I have taken one cookie packet and and gave that one packet to him, right? Now second child is demanding for two cookie. Second child is demanding for 2 cookie. Whether I have 2 cookie? No, right? There is no packets with 2 cookies, so I can't give him. And this third child asking for 3 cookies. Whether I have 3 cookie packet? No, there is only 1 cookie packet, and I cannot give that, right? So we can take this next example: 1 2 and 1 2 3. See here, g is equal to 1 2 3. Sorry, 1 2, and s is equal to 1 2 3. Right? Now this first child is demanding for one cookie. Whether I have a packet of cookie where I have 1 cookie or 2 cookie or more than 1 cookie, right? I have 1 cookie. I can give this to him. So take this and give this to him. So I have satisfied one children, right? Now the second child is asking for 2 cookie. Whether I have any packets of 2 cookie or more than 2 cookie? Yes, I have a packet of 2 cookie. Just take it and give it to him. 2 cookie. Now another child is satisfied. Any other child there? No. Totally there are 2 child. 2 child also satisfied. So what is the answer? It is 2. This is my output. I can also see here. I can also take like this: 1 2 and s is equal to 1 2 3. See carefully, for this one I can also give this cookie. Yes, he is asking for, I want 1 or more cookie. I have given totally 3 cookie packet, right? So he will happily satisfied. So the output, in my output already I have 1 children. Now take this 2. For 2 I want to give him the packet of 2 or more cookie. So I just take this two cookie packet and give the cookie to him. So another child is also satisfied. So the output is 2, right? This is another way. But still, whether we want to do like this or we want to do like this, the answer is we want to do like this. Why? Because just I may explain you with another example, right? Just see here. we have G is equal to 1 and 2. Now S is equal to 2 and 1, right? In this scenario, for this child who is demanding for 1, I can either give this 2 or I can give 1, right? First, I can give this 2. He will happily accept it and one child will be satisfied. Now, for this second child who is demanding for cookie 2, there is only one cookie packet. No, right? So only one child is satisfied. But if I take the same array and approach in different way, if I take the same array and approach in different way, like for this first child, I can take a cookie packet of 1, and for the second child, I can take the cookie packet 2. Now the output will be 2, right? Whether this is maximum or this is maximum. This is maximum. This is maximum. So from this problem, I can clearly state that the approach is, I want to take a cookie packet which is nearest and greatest to the element. That is, if take for example, 1 is the demanding cookie. It's a demanding cookie. It's a grid factor, right? Now I have say 2, 4, 5, 6. These are my cookie packets. Whether I want to take 2, 4, 5, 6, which way I want to take? I will take 2, right? Because see here, 2 is nearest greater than 1, right? If I have 1, 2, 3, I will definitely take this 1. If I have a grid factor of 10, this is my grid factor. Okay. Now I have 9, 11, 12. I will definitely take this 11, right? Because by taking this 11, it is a nearest cookie capacity which will satisfy the grid fact, right? So this is my approach. So this is basically a greedy problem, right? And this is basically a greedy problem because we are just picking selectively. We have a total n number of combos, right? For this 10, we can take 11 or 12, right? But still we are picking a specific element, right? So this is called greedy. Here to optimize it, we can use greedy, but still we can solve this using the 2-pointer approach, right? We can solve this in a 2-pointer approach. Because why I am saying this 2-pointer approach, we have already studied that 2 input pointers, right? 2 input pointers, right? Like see here, it is 1, 2, 3, and S is 1, 1, right? Now I just sort this 2 array. And point here. As these both are in a sorted array, always the array elements are increasing order. Here also the increasing order. So that my conclusion is, I can find immediate greater element for this grid factor, right? So my approach is 2 pointers, and it is what? It is what type of 2-pointer? It is a 2-pointer in which we will take 2 input 2-pointer type, right? Now let us take another example. Let us take grid factor is equal to 2, 1, 3, and S is equal to, take for example 4, 1, maybe 3, 5, right? Now my approach is, first of all, I tell my approach. We have studied that we want to sort both arrays. Now I can take a pointer here and another pointer here, right? Another pointer here. Now listen carefully, whether this 1 and this 1 are same. Like our condition is S of I should be less than or equal to S of j, right? Whether this 1 is less than or equal to 1. Yes, true, right? So I can make result as 1, right? Now just move the pointers. Here's one pointer and here's the another pointer. Whether 2 is less than or equal to 3. Yes, true, right? So just update. Another child also satisfied. Now update this pointer. Update this pointer. Now whether this 3 is less than or equal to 4. Absolutely yes. Absolutely yes. So update to 3. Now this pointer moves outside, right? While updating one, it moves up outside. So my final result will be 3. So this is my approach. Right? We want to sort, because we want to find the immediate greatest number, because I have told you some cases right here. In this case, sorry. Yes. In this case, 1 2 and 2 1. For 1 we can take 2 and 1, but taking 1 is the most efficient way, right? Because if we take this 2, then we cannot give the child who is demanding for two cookies, right? So this is why we want to careful while solving these types of problems. So this is the problem in which we are using combinations of 2 pointer plus greedy, right? So this is what approach. We can solve it and we can write the code. See here, this is the wrong approach. Don't do this, right? Many people are like taking combinations of every elements and checking whether those elements is satisfying the conditions, and they will cleverly put this g of I is equal to -1 and s of j is equal to -1. But still, these types of questions, these types of answers will be failed in some edge cases. Fine. So this is the wrong approach. Brute force, but still this is a wrong approach. See here. Just I am running the code. You can see which case it will be failed. See here. In some cases it is failed, right? Why? Because in this approach, like I have told you earlier, see here, like this only. When we are taking this one, we take this 2. We take this 2 as my cookie packet. For this 2, I only have this 1. Whether I can give this one cookie packet to a child who is demanding for 2, no, right? But still the answer can be 2. But because of our approach, the answer is 1. So this is what the problem of this brute force solution. So don't do this brute force solution. Instead of that, we can use the greedy plus 2 pointer approach. How to use the greedy plus 2 pointer approach? I have already told you that first sort the 2 arrays, then f is equal to 0, r is equal to 0. Now see here, both are less than their array size. That's the condition. If g of f is less than or equal to s of r, if the greed factor is less than or equal to s of r, I can satisfy the child, right? So I will increment my count plus 1 and my 2 pointers to plus 1 plus 1. Else take for example a simple example. If I have an array of take for example 5 6 7 and another is only like 4, sorry, okay fine, 4 10, right? Now first here's my one pointer and here's my another pointer. Whether this 5 is less than or equal to 4, whether this 5 is less than or equal to 4, no, right? No. Then I want to move this pointer, or I want to move this pointer. I want to move this pointer, right? I don't want to move this pointer. I want to move this pointer so that my values will be increasing in the towards the right side. That's the property of sorting, right? So I can move this to one pointer and point to this 10. Now whether the condition satisfy, g of I is less than or equal to s of j, right? Now pick this and pick this, update my result. So update will be 1. My result is 1, so output will be 1, right? This is the approach. Okay, so that's why I have wrote here, like if g of f is greater than s of r, just increment my r by 1, right? Then at last I am just returning the count. Now let us submit it. So talking about the time complexity and the space complexity of this solution. First of all, time complexity is, see here, we are using sort of function. So it will be, what is, let us take the size of g. Size of g is n and size of s is m, right? So upon sorting, the time complexity will be n log n plus m log n, right? And we are traversing whole array one time, so it is n plus m. So this is the exact time complexity, right? Now what is the space complexity? Space complexity is n plus m, because while sorting, as we know, the internal sort algorithm uses the merge sort, and while sorting this, we want, in worst case, it will be O of n for sorting this n elements, and sorting this m elements, we want O of m, right? So that's why the space complexity is n plus m. So this is the approach we want to use here. So this is a 2-pointer plus greedy approach, and make sure don't make this mistake, right? So this is what approach. Thank you.